Okay, we're on the internet.
Finally.
Yeah.
Do you have a URL for that around, Alex? Is that in the email? Is that what you posted there, Shelley?
Yeah.
Great. Oh, brilliant.
Yeah. It's on the international conference. Yeah, so if you want to share this with people, then the URL to share is either the YouTube one, or people can go to forum.toplap.org and go to the hybrid live coding interfaces bit, which has the URL. Oh, that's not very good. Sorry, this is a bit of a soft launch for the workshop. We're just kind of sitting around having our coffee, chilling out, being a bit awkward, as you should be in research workshops.
Yeah, realistic experience.
Yeah. So yeah, should we sort of kick off? Jack or Shelley, did you want to kind of say why we're doing this?
I'll go first.
Yeah, what does hybrid live coding interfaces mean?
Well, I was going to say, I feel like it's I don't know whose fault it is the most that we're doing this, but it might be mine. I can't remember. But yeah, so I think around January we started thinking about this workshop, about bringing together some different streams of work that we've been doing ourselves, and then looking at ways to bring together more people in that conversation. So the image that you're seeing on screen now is a project that I did a while ago called the Stenophone, which unfortunately was never finished, but maybe I'll come back to it after my PhD is handed in. And in that project, I was looking at coming up with a physical device that was tailored towards live coding in the same way that an instrument maker might design an instrument for a specific type of music. And so, you can do particular types of gestures on it that kind of led me to question a lot of things that we take for granted about live coding, that it's about text in a text editor, and it's about sitting down on stage and typing, and all of that kind of orthodoxy that we're quite familiar with. And I'm sure I'm not the first person to ever sort of start questioning that. And I think there's so much that we can explore, in terms of dance, in terms of bringing all kinds of different art forms into this, into contact with this community. So that's what's been motivating me, and I'm just a bit overwhelmed by all of the amazing responses that we've had, many more than we could have run a 4-day workshop quite easily, but we didn't this time. So yeah, I'm just really happy that other people have connected with this kind of brief that we did, and I'm just really grateful for everyone to come together like this, and really excited to see all of the presentations. So yeah, thanks very much, everyone.
You are now unmuted.
Over to Shelley.
Oh, I'm so not prepared for this. I got sort of brought on board with this project by Alex and Jack, because I've been thinking about coding and I guess I don't want to say AI because I really hate that term, but like sort of forms of like computational agency, some working a bit with machine listening and sort of integrating that into live coding performances, either from the perspective of collaborators or from working with databases of sound and finding ways to sort of reorganize that in live coding performances. And so, and I think there's also quite a lot of activity going on in that sort of area of sort of machine learning and machine listening and live right now. So I was sort of interested in, I guess, looking at those sort of futures of combining live coding with various forms of machine intelligence, let's say that. So yeah, that was sort of my angle coming into this. And yeah, I guess I just want to reiterate what Jack said, that we had like so many really super interesting submissions to this that it was like super difficult to get it down to just a 6-hour workshop. So it's been really nice to see like the diversity of what people are thinking about when they're thinking about sort of expanding live coding out into other sort of hybrid forms of creative practice, and also just the super interesting projects that people are doing, and the level of interest as well in sort of thinking about this.
Okay. Shall I? Is it my turn?
Yeah.
Okay, cool. I'm really happy with all the responses as well, and I guess hybrid live coding interfaces for me is sort of opportunity to take a longer view on live coding as well. So not just think about what we could do in the future, but what people have done in the past. So nice that people have contributed with ideas from quilting and things, which isn't necessarily making brand new interfaces. Well, it probably is actually, but also thinking about how people have always worked with codes and patterns and things which are algorithmic, and how I'm not used to wearing glasses yet, obviously. How we can sort of think about live coding as becoming more embedded in culture, partly by making hybrid interfaces that are part of lutherie and instrument making that have a longer history, but also key in with more conceptual ideas from craft from the last millennia. So yeah, super excited to see what people have to say about that. It's going to be a bit experimental. There might be some glitches, but we'll just have to try our best. So far, it seems to be working all right. We're using something called Big Blue Button for the video conferencing, which is then streaming onto YouTube. Let us know if there are problems with audio or anything. We'll try and sort that out as we go. If you've got questions, then that can go either in the YouTube channel or straight into the forum on toplab.org, forum.toplab.org, in the hybrid live coding workshop section. There's a different post for each session. There's 4 sessions. We'll be collecting all the questions, whether they come through the video chat or through YouTube or the forum, so that they're all in one place on the forum where we can continue our discussion after the workshop. Because we've got lightning talks, they're all 10 minutes each, and only 5 minutes for questions. So I think those questions will just be starting points for ongoing discussion. Simon's getting some nice comments about his squeaky chair. I think Simon is known for making music out of strange objects. So That's all good. And I think we're just about ready to start with the first presentation. So I think Shelley is moderating the sessions today and tomorrow on instruments. So I'll hand over to Shelley.
You are now muted.
Hi, I'm back. So this is session number 1 on instruments, and we have 5 talks in this session. And just so speakers know, I'm going to give you a 1-minute warning of your time for speaking being up in the chat. So maybe just keep an eye on that. In order to keep to, we will go straight to the first speakers, which is Anne Feinberg and Felipe Ignacio Noriega. I'm so sorry for that pronunciation, who are going to talk about code clavier.
Okay, so thanks, Shelley, and thanks everyone for the invitation. And basically, we will do this really kind of lightning talk to tell all of you about our project, the Code Clavier, and also kind of the experiences we've collected in the past 3 years. But before that, I'll go back a couple of months ago to the summer because, like, to my surprise, I bought a guitar, like an acoustic guitar. And I think this really related, it kind of motivated us for the NIME lightning talk also because, you know, I normally, like, for the past, I don't know, many years now, I've just been coding and making music with code. And I got this commission where I had to do a children's song with guitar. So I tried to do guitar samples and algorithms to play the guitar accompaniment. And then I tried to maybe make guitar sounds on Super Collider. And then I tried to make patterns to play different chord progressions. And basically, I was just getting the piece returned. You know, they were not happy, to the point I said, like, okay, I'm just going to get a guitar and just play the guitar and play the chords. And it felt so good. It felt really good. And that kind of brought me really back to this feeling of having an acoustic instrument or an interface that just really quickly and really intuitively just responds to your movement and responds to your gestures. And you don't have to think so much about the pattern structure or where you're going, but you're just sort of getting in a musical flow. I was just very surprised. I hadn't played guitar for maybe, I don't know, 20 years. No, that's too much. 15 years, and it really brought me back to understanding the power of acoustic instruments. And this is also related to the Code Clavier, because what we wanted to do here is actually, instead of creating a new interface to be able to code, we wanted to use an existing instrument where there's already a big practice or performative practice, and try to incorporate that practice or repurpose that practice and those gestures to be able to generate code. Another thing that really became clear to me once I was doing this guitar experience is that although still an acoustic instrument and an interface feels like so good, so intuitive, and so expressive, I also feel that live coding languages are becoming like really developed in a good way, in a very high leveled way, or maybe assisted way, where we are able to code like way faster, way more expressive, and in more musical terms than we used to, years ago. And that's like a great development to see. Still, I feel that, that there's a long way to go in this development of DSLs, but it feels that one day, hopefully, all these kind of coding languages will reach a point where we can also code and live code and get the same feeling we're getting as if we were playing an acoustic instrument. And that's kind of what we're trying to do with the Code Clavier, and that's where I'll give the word to Anne so she can tell us about what's going on, because she's the one who really codes with the Code Clavier, not me.
So what Felipe was saying was that he thinks that coding has becoming more high level, and it's really moving to a point where you could code with an acoustic instrument, and that's kind of always been the goal of the Code Clavier. And it's very much with the Code Clavier, we're trying to really rethink the musical instrument and make it not just a musical instrument, but really an instrument for coding. And I really use the word instrument consciously over interface, and I'll kind of try to talk about that a little more. So for those of you that don't know our project, the Code Clavier is a system that we're developing which allows a pianist to code by playing the piano. We use an acoustic piano, but it is MIDI powered. I'll send the link to our website if you want to find out more. The idea behind it is that, well, first of all, the piano, because of MIDI, is also really easy to use as a very stable interface. But what we really wanted to do was build upon the very rich piano practice and see how we can apply that to coding. Oh, my cat is meowing like crazy. Something that we've been doing in the past year or so is actually working with external collaborators that are building the coding outputs. So Felipe has kind of been developing the core of the Code Clavier, which deals with the piano input. And then we're working with Joanna Chikau for a JavaScript extension, and Craig Lata for a Caffeine extension. And Sebastian Papalardo is working with Hydro to make a Hydro extension for it. And then Timo Hochland. Oh, fuck. Sorry. Oh, my goodness. Hold on. I have to go.
Okay. I'll take over. Anne just has a new baby. 8-month baby, so probably something happened. So let's hope everything is okay. I think where Anne left it is that what we're trying to do to also extend the language or our experiment with the Code Clavier is that we started to collaborate with more people. And thanks to that, to trying to let the Code Clavier communicate with other environments or DSLs, we've encountered like a lot of problems.
I'm so sorry.
And also good problems, but okay, Anne is back, so go on. I was just developing your extensions thing, but you can just probably move on.
My cat was in a fight. I'm so sorry. We've been working with these external extensions, and it's been really an interesting approach because then we're having the Code Clavier core, but then we're dealing really with another language. And what's kind of become really apparent that languages need to be developed in relation to the interface. Otherwise, it's a huge struggle. So time and time again, I'm working with one of the collaborators, and they show something which is super easy with their system, and it's like super a hassle for me to actually do it. Like a really good example is not having a mouse, like trying to code without a mouse, which is really problematic in JavaScript, for example, or generally like navigating the code, replacing, copying and pasting, stuff like that, which I think a lot of people take for granted and so inherent to their system. And then with Code Clavier, it's quite difficult. So that was kind of what we came to realize, that every language really needs to be developed in relation to the interface. And essentially every NIME needs its own DSL. But there's one difference, but we also collaborate with Patrick Borja, who's building an AI extension. And there we really work together from beginning to end. And then it really feels different. So that's how kind of, and then you see the appearance. So that really makes a huge difference when you're really working on both sides of the language and interface together. And that's why I really think it's important that we're thinking about not just the interface, but really the instrument. I think it's that's, for me, is a really big difference. Okay, Felipe?
Yeah. And just to kind of start rounding off, we can tell you like where we're at now with the extensions, and how much we've been able to actually let Anne code by playing the piano, and like to which point we feel we still need to develop a lot more. And basically, like where the Code Clavier right now is, its current state, its more stable state, is that there is some sort of definition program or definition file, let's call it, where you can define a lot of the constructs for the Code Clavier. It's like I imagine it's like a punching card, and you punch like the different holes, and then you feed it to the Code Clavier, and the Code Clavier then knows how to interpret the piano. And that can change also live, like we're able to change those definitions live. But basically where it's right now is that Anne writes that. So she has to learn kind of the syntax for that. So it's like a little mini program in the Code Clavier. Anne needs to program that. And then Anne needs to boot the Code Clavier with that specific file. We call it an ini file, so like the booting configuration. And then the Code Clavier interacts with that and with the piano based on those definitions. And it allows for conditionals, it allows for real-time reading of values and kind of different stuff. I won't go into detail there, but like what we feel is important to mention probably for NIME is that like what we want with the code clavier eventually is that Anne as a pianist doesn't necessarily need to learn another language, a programming language, or in this case, kind of the syntax for writing the booting definition files of the code clavier. It'd be great if she could literally just play the piano, and then as she's playing the piano, allow, through the code clavier to convert or transform or interpret those gestures and those melodies and those chords and those musical patterns into computations. And in a way, we feel we're getting there slowly, but the definition of this file, of this booting file, is still kind of, it's great to do it because we can load a whole different types of definitions or sort of subprograms for the code clavier, but it's still like work that Anne has to do, and Anne has had to learn about it. And maybe she can tell us about what that feels, or we can just round it off here too, because I think it's also time.
Well, I think Shelley kind of said she doesn't want to talk about AI, but ultimately we need to have a helper, so some sort of machine learning, artificial intelligence, to take away some of this very some of this work of manually putting in the motives and the snippets. But what we really would like to hear from you today is, because we've been really thinking a lot about this, rethinking the piano as an instrument for live coding, but we've had this struggle with this idea that the language really needs to be thought about from beginning to end. It's been a really great experience to explore otherwise, but it's very also, you really see how you need to develop it. And I think actually Jack said this at ICLC in Mexico, that at one point he actually really wants to build a language for the stenophone, not using Super Collider to make the sound. But yeah, I'm finishing off. So all I want to say is it's really great to be here, and we just love to hear from you guys, how you guys have approached this hybrid instruments, and if you have similar experiences, and hope we can learn from each other. Questions?
Thanks, Felipe and Anne. That was a really interesting talk. And yes, please get your questions in and we will try and ask them. I just wanted to say, actually, I didn't mean to say that I don't want to talk about AI or I don't AI. I just meant that I really don't like the term because it doesn't really mean anything, or it's not very well defined. That's what I meant to say. Yeah, while we're waiting for questions, maybe I will ask one. And I just wanted to ask how the practice of playing the code clavier is different to the practice of playing the piano, and whether you feel restricted or whether you have to play the piano in a different way. That yeah.
Yes, it's very, very different. In fact, I even have a term for it. I call it piano coding. The biggest thing is that I'm really thinking a lot about the coding out results of what I'm playing. I find it very difficult because your brain is really divided. So it's like running multiple heavy programs on your laptop, and then one is kind of always struggling. So for a start, even though sometimes my playing itself is quite primitive, as in easy, I have to always be in pretty good piano shape to be able to get that along, because it's just running. It really has to be like supernatural, everything I'm doing, because I need so much processing to like think about what it is that I'm trying to do. And the other thing is that it's it's confined to what I've set out to do in the ini file when we talk about using these code clavier with these extensions. We also have a different code clavier, which is the C calculator, which is no input in beforehand. So everything is really done live. And then I can think much more about what I'm coding right at that time. I mean, what I'm playing right at that time.
We have another question, which is, have you thought about trying and exploring SEMA, which is, I believe Francisco is here, but it's a new platform for live coding design for DSL creation?
Not yet, but we'll check it out. That's like one of the reasons it's great to be here and hear ideas.
Yeah, thanks for the tip. Yeah.
And another question which is coming from YouTube, Jonathan Royce. I wonder if they've encountered any experiences where the mental work of remembering the state of things is somehow translated to muscle motoric memory and playing.
Yeah, for sure. Especially a lot of things becomes very motoric, and I think we even so then I have a tendency to pick certain things, especially with parameters that feel very nice to play, feel and sound nice to play. So things that have a lot of fifths and thirds, for example, are very popular for me because it just feels good. Oh, and octaves, fifths, thirds, and octaves. Yeah, I'm a contemporary pianist, but then I go really back to basics for this. So motoric and muscle memory translates a lot into it. And I think that's one of the really interesting things we want to explore, because then you're like within the limits of what I can do to code, I also have this like natural piano stuff coming through. So I always pick slightly different variables than say someone that's just doing numbers might pick. Does that answer the question?
It answers the question for me. Yeah, great. I think that's all we have time for, actually. But thanks so much for your talk. And I think we will move on now to.
I just want to very quickly thank Patrick, because he's allowing me to use his casa and his Wi-Fi and his setup. So thank you, Patrick. That's it.
I also want to apologize for running off. My cat was in a fight and I just I couldn't hear her crying like that. I'm sorry.
I hope your cat is okay.
Yeah, it's okay. But I'm sorry. Okay.
No problem. Thank you. So I think we can carry on the conversation about that via the various chat things and the forum. But for now, we're going to move on to Manyo Kalaman, who I hope is here. Oh, I have to make you a presenter. That's what I need to do.
Okay, now I have the camera.
Super. So I'll just hand over to you to start your talk.
Yeah, but what is the slide thing again? Sorry.
Bottom left, there's like a plus button.
Oh yeah, there you go.
Yeah.
And let me just upload it then. There it is. Okay. Is it showing? I think it is, right?
Yeah, we're good to go.
Great. Okay, so, well, my name is Magno Kaliman, for those who don't know me, and I'm going to talk about mediation and quote-unquote object-specific creative process in experimental live coding. Just quite of a mouthful of a title, I admit it, but I think we're going to go through all of the terms in it in the next 10 minutes or so. But basically, I want to talk about some stuff that happens when we have technology as mediators for our artistic practices. So technology, when it's placed in this position of mediator, so quite literally in the middle of the process between an artist and its final art object, has this capacity to influence / shape both the process, so how we make things, as well as the final output, so the result of that process. And just to give one very straightforward example that doesn't have to do with live coding, but if you think about Pierre Schaeffer's music, the very first generation before tapes, when he was doing music with the, what's it called in English, the Schlag discs, their repertoire has the loops that he used. If you listen to it, those loops are very fast. Well, they're very short. And so you don't have, big 5, 10, 15-second loops. They're all really short, 1, 2 seconds. And that is a direct consequence of the size of the disk, right? So if you have a disk this big, you can have a bigger loop than a disk that is this big. Again, a very straightforward example of how an intrinsic characteristic of the technology that you're using can shape and be a direct responsible for a characteristic and one of the parts of the piece that is the final output that is made with the technology, right? So how does technology exert this influence that I'm talking about? It does it, and this is my proposition, by showing its limits. So when mediating art making, technical objects can reveal their boundaries. So the technical object that you're using, I'm using Simon Donström here, when placed in this position of mediator, shows its own boundaries, its own limits of operation, right? So when that happens, a certain dynamic is set in motion that I think it's interesting, which is a dynamic of negotiation, a sort of presentation of terms, a negotiation between the artist and the technical object. And what do I mean by negotiation? Again, very straightforward example with the Schaeffer discs. You cannot have loops bigger than 2 seconds because of the physical size of the disk. But you could slow down the rotation speed of the disk. Then you get a bigger loop, of course. But from that, you get the kind of a side effect of everything having been pitched down, right? So the artist is pulling on one side, the technical object is pulling on the other, and there's a negotiation that happens between the two, right? Sort of okay, you keep the house, but I keep the car. You want bigger loops, everything's going to be pitched down, right? So there's a dynamic that is set in motion. So in a sense, we can think of the technology that is being used, the technical object, as delimiting a zone of possible actions, right? It locks things in place in the creative process. It says you can do this, but you cannot do this other thing. And when we're talking about experimental practices, that creates an interesting condition where finding places to occupy becomes part of the composition process. What I mean by finding places to occupy, if you think really in terms, quite concrete terms, where the technology is kind of like this physical object, you're inquiring that object and trying to find characteristics of that object that somehow you can speculate with. And from that speculation, some sort of poetic process can arrive, right? And this is what I'm calling entry points in my research. So you're looking for ways that you can take that object and pull it apart and find ways that it work or modes of operation, right? And I'm saying object here, but it doesn't have to be a physical object. It can be a computational object, of course. So to engage speculatively with a device, to have technology itself as the place for creative inquiry, becomes a process of navigating and mapping that frame, discovering its terms and testing its boundaries. The work reveals itself in those actions. So the actual piece, the actual artwork, is somehow revealed and is created when you're investigating your object. And I have this, sort of abstract image of how the artist is constantly finding new paths that he can follow by inquiring its technology, the technology that is mediating its process, right? So he finds a place and that's a dead end, and it comes back and goes to another one and chooses another one. Said from here I can go there or there. I choose this one, right? So what I'm trying to say is that there's a certain creative process, creative compositional, if we're talking about music, compositional process that is born out of the object itself. So if you think of the technical entity, the technical object as this orange diamond thing, it is in the center of the process. Everything spawns out of it, right? And there are other possibilities. Of course, I'm not saying that this is how you make music, how you make experimental music. It would be very dumb of me to say that. You can have several other things in this center. You could have, pitch manipulation, anything from Britney Spears to Xenakis. If your jam is to create melodies or manipulate, pitch, set, class theory, post-tonal, whatever, fine. That's the center of your process. You could have philosophical inquiry as the thing itself from which all the process spawns out of. So when Lamontian makes a piece and says, this piece is comprised of butterflies flying in a concert hall, and the piece ends when the butterflies fly out the door. He certainly has something else in that center, maybe some sort of ontological questioning about the nature of a music work. You can have making people dance as your main motivation. You sit down in front of your computer and you just say, I want to make the sickest beat ever made, and that's the beginning of everything, right? But what I'm proposing here is that maybe there is a certain process, a certain way of working where the object is in the middle. Hence, the object-specific, which is the term that I'm proposing, object-specific creative practice. Just like you have site-specific works, it might be fruitful to think in an object-specific creative practice, right? Where the entity, the technology that you're using is at the center of how the work is made. And when we're talking about custom interfaces for live coding, for example, this is potentialized by a factor of 1,000, right? If you think in terms of a somewhat traditional workflow of designing an interface, learning how to use that interface, and then creating something with that interface. And if you think about that as separate entities, when you're creating the interface yourself, those processes are pretty much almost simultaneous, right? It is impossible to separate the stages of creating a piece of work and creating the technology that work is made with when we're talking about custom interfaces, right? And Code Clavier is a very good example of that. Tomorrow we're gonna have I think it's tomorrow, right? Someone talking about using a guitar, an acoustic guitar as interface for creative coding, right? So what I'm trying to present here, and this is like one before last slide, is trying to show a mode of working that I think is very much familiar to experimental practices and to the development of custom interfaces, where the artist is constantly jumping between two states, where he's inquiring technology that he's using, sometimes creating that thing and trying to find, like I mentioned, those entry points of, I can make a piece out of this. There's this characteristic that is interesting, and jump into another state where, but from that characteristic, maybe I can make a piece like this, like the other, but this is not that interesting. I might come back and implement a new feature, right? And you're constantly bouncing between those two states. And I think that's something that happens a lot when we're working in experimental practices and when we're working with custom interfaces for live coding, right? And because we're here to talk and discuss, I finish with a question. Like, how much are you aware of this negotiation that I'm talking about in your own practice? How much can you see things in your own music, in your own art, that you can say, I think this is a direct consequence of an intrinsic characteristic of the technology that I'm using? And with that, I finish.
Thanks, Manu, for that presentation. It's interesting to think about those creative processes. And yeah, for me, I think this is when I'm live coding, this feels like something I'm actually sort of while on stage and while performing, and not just when I'm making the piece. I don't know if you feel the same.
The audio caught up a little bit, cut down a little bit. Can you say it again? When you're on stage, what?
Yeah, I just as a live coder, I'm also going through this design process and sort of speculative process also when I'm on stage and performing, and not just when I'm sort of thinking for the performance about the piece. And I wonder if that's something that rings true for you as well.
Oh, okay. So that, like, in the actual moment of performance, as in, well, I want to do this, but it would take me 40 lines of code to do it, or maybe looking up the documentation, so I might not do it, and I might find some other solution. Yeah, that's for sure a parallel. And that's the thing, like, maybe on a different language, that thing would be easier to do. I mean, easier. It would be possible to do with just a couple of lines, and you could do it really quick, right? So again, a direct consequence of the end result of art making that is completely dependent of the intrinsic characteristics of the system that you're using. You know, if you're using super collider instead of tidal cycles, you have to do very different things to get the same result, right? So yeah, for sure.
Yeah, definitely. I mean, I definitely feel that as soon as I tried to work with PDEFs in Super Collider, my head starts hurting.
Exactly, yes. Give me 6 minutes and I'll have the sickest beat here. Yeah, like, of course.
Yeah, exactly, yeah. You had some really nice examples in your abstract, so I wonder if you want to talk about one of those for a couple of minutes while we're waiting for some questions.
Yeah, because I removed a lot of the examples because I didn't because of time constraints. But I'm just gonna, since you mentioned, I'm gonna put here on the chat a video from this was when was it? Was in Spain, so it was 2019. The piece that I played at ICLC in 2019, which is a live coding for Arduinos that I did with 4 or 5 Arduinos connected at the same time. And the whole piece, all of the characteristics of the piece spawned from the limits that I had of being able to just communicate with one Arduino at the same time because of how the serial port worked. So the piece ended up, I mean, not to take a lot of time, but everything from the visual aspect of it, which is me using a whole bunch of keyboard shortcuts to change the serial port really quick, which is something that I had to rehearse. Like I haven't rehearsed like in a guitar piece for a long time. So the visual part of it, all the way up to how the piece is structured, since I could only send the same code to different boards or like code with small variations, the piece ended up sounding almost like a fugue. It gained like a stretto fugue type of quality because I would send the same code and then a little bit of a variant to another Arduino and then another variant and another variant. So you hear the same motif being repeated over and over and over again, which was not something that I intended to have when I started writing. It was a direct consequence of the fact that, yeah, okay, so I have to work with that. So has formalizing your reflections on these negotiations, like in the presentation, in turn change how you negotiate? Yeah, for sure. It's been, and this is what I want to. Well, a disclaimer is in place here because this is very, very early research. Very early, as in I started a PhD next month, as in I didn't even start it, but this is the beginning of the research that I'm going to start in September. So there's 110% questions here and is minus 10% answers. But for sure, it makes you, once you formalize those things, it makes you aware. And that's why I wanted to have this last question at the end. Like, how much are you aware that, you know what, maybe I want to go around those what I'm calling, limitations or boundaries of the thing that I'm working. Like, to give really concrete examples, like, am I making dance music because it's what I want, or it's because it's the path that language X, Y, Ableton Live, whatever pushes me to, right? Okay. So once you're aware of that, you can maybe negotiate and say, you know what, I don't accept those terms. Instead of making, like if you're using Sonic Pi, just to give like a concrete example, it's a very much note oriented. So you do your, notes and sequences. Okay, but I'm just gonna have then a delay time of 0.0001 second, and I'm gonna force this interface, the system, to become a synthesizer, which was not designed to do, right? So yeah, once you formalize and you're aware of those things, at least for me, it's an interesting way of, okay, how can I force to navigate exactly, because that's interesting for me, navigating those boundaries. If you've seen me play in any of the ICLCs, I make noisy experimental music. I don't make people dance. So I'm interested in operating in those boundaries, in the places where things start to fail, where they're not supposed to work. So yeah, for me, and being aware of where their boundary is for my practice, completely integral. Yeah, for sure.
Well, we're a little out of time here, but I hope this conversation continues on the forum, which I'm going to say after every talk, because I'm sure there are a lot of questions that people didn't quite have time to formalize yet. So yeah, thanks so much for your talk.
Yeah, thanks for having me. So I'm going to shut down now.
Great. And we're moving on now to Evan Raskob, who I can see is here. So I'm going to make him the presenter, and hopefully he will join us with his audio and video any now.
Hello, can you hear me?
Yes, we can. Welcome.
Fantastic.
So over to...
Let me, I'm just going to upload my presentation right now.
Yeah, my slides are still up. How do I remove them?
I think once Evan puts his up, yours will disappear.
Okay.
Okay. 40%, 50%. This is the most exciting part.
The anticipation.
Yeah, that's it. We need a ominous music in the background. Okay, processing. Good. There we go.
Oh yeah.
Okay.
All right, over to you.
Great. Thanks, Shelley. Can I? Nope. So yeah, I'm going to talk a bit about Live Printer. I think it's really interesting to talk about this, especially compared to the last two pieces, because this is sort of the end of this PhD I've been doing over a period of years, maybe 6 years now. I think I'm into it, and there's been a lot of research and a lot of development inside that, and a lot of it is really about this idea of language, situated language, and the idea that when you're building live code language, it's sort of the research process is sort of about you at the same time. So, I mean, I got to give you a little background first, because part of it is, this is 3D printing. So, if you look at the types of manufacturing, you've got that inside additive manufacturing. So I've got a really small space I'm working in to be very specific. It's all about depositing material, not all the rest of these, which can get very complicated. So I'm going to breeze through some examples really quick to give you a background. There's some interesting things where people have been playing with algorithmic shapes with 3D printers, like gcode.clay, where people have been messing with the G code, which is the underlying code that describes shapes. I really like this project. I've seen also at the Bartlett, they've been working on this sort of air printing using this not quite live coded robot, because you really don't want to live code a robot because it's incredibly dangerous. But they've made some really amazing shapes, and I've been able to, in the course of that, do some kind of air printing on the cheap using like a really super low-end printer, the old school Ultimaker 2. So I think, in a sense, I've shown that if you can really play with 3D printers on a code level, you can make some really funky different forms. Let's see. So what it works in is normally 3D printing does modeling, toolpath planning, and then fabricating. Okay, so it's like a 3-step process. Normally you work in the modeling stage, and software takes care of the toolpath. And then fabrication is a bit of a sort of technician style, more hands-on machine process. So, and sort of looks like this. You render a donut, you turn it into triangles, you try and find different toolhead paths throughout it, and you render that to this G code, which then the machine runs. And I tried live coding G code at first, but clearly that is incredibly difficult and not very useful to do, because you have to keep in your head all these different hard-coded coordinates. So didn't work very well. Much better to let machines do that and render. So I've got a system called Live Printer, which does this live. Basically, you do some high-level language, it renders that into G code, communicates with the printer, manages a bit of state. So it's got the front-end editor, and then it's also got the sort of state manager server attached to it. So it's a fairly complex piece of software. I think it's like 20,000 lines of code now. But, oh, can I play the video? No. Oops. Okay, I need to paste the link. Sorry, my video didn't transfer into my slides. I was going to show you, I've done Hilbert curves live coded in 3D printer, which I'll post after this chat so you can see that. To give you an example of sort of the live coding of actual tool paths and materials and all the rest of it at the same time, which is something that you just couldn't do before that. They didn't give you that kind of option. So yeah, this is what it sort of looked like. This is an older version. It's got a funky sort of plasticky design. I think, a lot of times we don't think about the aesthetics of these designs. This was a sort of blocky early version. But I've got the newer ones look a bit better now that I've refined it. But what you're doing is, what you have to mostly control is temperature, speed, position, and filament. And I think it's interesting because we've had this discussion about, language and situated language. And with live coding, I come at it somewhat from a coding standpoint, but also from a design standpoint. And I've done these user tests with designers, textile makers, people who don't do any coding, and it's interesting because you have different terminology and you use different, just different terms for what you do. And what I found, which is really interesting, is that 3D printers were also made by engineers, right? They kind of descend back to the RepRap, which is one of the first versions of the 3D printers that was made for the desktop. And it's very much like an engineer's idea of what the terminology should be, especially with this idea of filament position. And retraction is a very sticky point, which is how they describe material handling. So, but that doesn't really mean anything to most people who are let's say product designers or even textile people. They want to get some plastic out of the nozzle. They don't really know about the mechanism inside that. And it's not always very useful to use that sort of terminology. It actually makes you think, since the terminology of how you describe this actually directly relates to how you design the machine, there's really sort of feedback process. And really the terminology and the machine should be designed at the same time along with the user. Okay, so really I'm working with, I guess, what Wolfgang Jonas calls the cybernetic theory of design research, which is that you have a practitioner developing this object inside of community in this sort of feedback loop. Okay, you design the language, you design conversations around the language, you design the object itself, and it cycles in this iterative cycle. And I find that a really interesting concept. I think it's something we could really take. I think, with the code clavier, I really like that discussion about how language need to be specific to the piano. I think making sure that we bridge these gaps with the community and we have real user testing and conversations about it, as well as we're working on the engineering and the language, is really complicated, but also useful. So I think I have a couple minutes left. I wanted to talk a little bit about some findings I've had recently that I've not really been able to type up yet. But I've used different methods of chaining, to try and get the language out to people. So as we know, when you try and type in an interface in a live coding editor, brevity is really key. But then how we create that brevity, how we use abbreviations is really important. And I experimented with a couple styles like L systems grammars, just putting in letters and numbers, which are sort of more almost like pattern matching in order to specify shapes. I looked at method chaining, below, where there's an example of, taking an object and then just chaining together a bunch of operations on it. And I looked at method cascading, which is, I guess, less used. I actually couldn't do this in JavaScript, so I had to write my own sort of MIDI grammar, I called it, as a syntactic sugar in order to to get that working. But I wound up with the method cascading in the end, which hopefully I have an example of that. Yeah, so you can sort of see here, this is a mini grammar. You have a, where is it? Oh, you can't really see the cascading inside this one. Hold on, did I put the wrong slide in? I didn't put the right slide, sorry. You can, the method cascading works because this gets compiled to JavaScript, and you have a sort of hash sign or pound sign, which specifies a function, and then basically object parameters. And then there should be another bit on that, like a pipe, and then you can then cascade methods together. So you can put a pipe and then another function with different objects as well. And that's method cascading because what it does behind the scenes is actually it takes the object, which is the instance of live printer, and it runs a function on it. But because everything is asynchronous, because it has to deal with a remote server and a printer, which does a call and response, because it's, of course, incredibly complicated, it can't just chain methods together, right? You have asynchronous things happening, so you have to run one, get a result of it, and then hopefully if you don't get an error, then run it with the current instance of the object again, and then run that. So to the user, this is just a mess. Like, you could code this in JavaScript, but then you wind up with lots of asynchronous function calls, and you don't really want to live code that. I mean, I have, I guess it's not really in this example I have here, but you know, you can imagine doing sort of promises and trying to live code promises and things like that in JavaScript, and it's a mess. So the idea that you can then use method chaining really helped because it brought the conceptual model closer to the actual user's conceptual model. So on the one hand, you have the mini grammar, which is here, which, you know, less punctuation, very brief, and then method cascading. And on the other hand, you have the sort of pure JavaScript everything compiles to, you know, yada, yada, yada. You get how that works. Happy to talk in more detail about that. But this brought up a lot of interesting points because, you know, if you look at documentation of 3D printers, sometimes they talk about travel, you know, because they talk in terms of the machine with the head traveling. But if you talk about what you're actually telling the print head to do or telling the machine to do, you kind of want to tell it just to draw things sometimes. So you want to use this sort of more like almost turtle graphics language. So I've wound up, you know, starting out with a more faithful representation of the machine in my syntax, and then moving towards a more community faithful version of drawing, and keeping everything more conceptually to drawing. And yeah, I think I'm going to kind of end with that on that prompt. I mean, I haven't been able to finish writing this up yet, hopefully sometime soon, but I'm happy to talk more about it. And there's some links to Live Printer if you want to play about with it. Thank you.
Thanks, Evan, for that perfectly timed talk. That's great.
Yeah, that came in right in time, didn't it?
Yeah, exactly on time. I'm kind of interested in just, I don't know, just the idea of like live coding with a 3D printer. It's like my experience of 3D is it's like so prone to failure and things going wrong. I'm wondering how that works out in live coded exploration.
I mean, if you've seen my performances, most of them have failed in some interesting way. Even the one that set off the fire alarm was kind of fascinating. But, you know, a lot of it was, to be honest, the hardest part was to get the material handling. That is really where the failures happen, because you've got to keep your material flowing in sync, and the material melts and it just drips. And, you know, it's very hard to keep to code and then have this dripping material. It's almost like a, you know, an hourglass timer, just ticking out your moments, you know, it can burn if you leave it in the head too long. And then just working out, you know, I mean, this is where, again, AI and machine learning, I think, could actually be really interesting, because, you know, having that sort of help you with different speeds and temperatures, you know, sometimes you want to just draw a line, you know, but with a 3D print, you have to think, how hot does my material have to be? Yeah. How long is that line? Where is it in space? How long do I pause to let the material cool? Do I turn the fan on? You know, I mean, I found it really interesting. I've learned so much about 3D printers using it, but I've also, found it a difficult process. It's for sure.
Yeah, I think it's like a super interesting like time-based exploration, because it's like when I'm live coding music, there's always like this time pressure of like you have to make something change and balance that with writing code and sort of changing the audio. But I guess there's like the literal possibility of fire with with your thing if you don't get the code versus thing happening bit right. So
yeah, exactly.
Interesting. There's a question in the chat, which is, has this experience changed your appreciation approach to physical form due to working algorithmically somewhat indirectly?
Yeah, I mean, completely. What I started to work on is this idea that you could create different algorithms as like building blocks to create shapes. And I think I resisted that at first. I really wanted to experiment with just, how could you draw with a 3D printer if you didn't have any limitations on it, and you could specify temperature and time and anything you wanted to. And now I think my paper at ICLC, or my poster at ICLC in January, was about Hilbert curves and this idea of, things that fill space, without a break. So you can sort of start these computational processes that create shapes that have some aesthetic in them and maybe some musical quality, and you can sort of build out of those tools without just constantly typing in lines. I think, it just really comes down to bridging between scales. Like, and I was reading a kind of critique of turtle graphics and, what's his name? Not Piaget, you know what I mean? Papert, about how, turtle graphics was great for drawing simple shapes, but, it sort of failed because, you really wanted to get to more complex shapes, and there wasn't really a way to do it, not a simple way. So, yeah, I think, trying to explore that gap is really interesting. Hope that makes sense.
Yeah, there's just a comment there as well from Anne. Physical limitations have their own artistic agency, which can be rewarding to interact with. I don't know if you want to say anything to that.
I think so. Yeah, I love the idea that there's like this thing that just can fail. I mean, it like it makes it, I think, more performance art in a way sometimes than musical art. It's like definitely musical, but yeah, it really does have its own artistic agency. And I think, another direction I go in is that, manufacturing, and especially mechanical manufacturing is moving into full automation. And this is really a pushback in saying, no, it should be more augmentation. Like, how do we explore those physical limitations within the human context rather than just design humans out of it? So I think failure is interesting in this case for that. It should be part of the process.
Well, thank you for the talk and for the discussion. And I think that's us out of time. So I think we are moving on now.
Great. Thank you.
Thanks. So next up, we have Ivan Abreu-Ochoa. I'm so sorry about my pronunciation, but I hope you are here. I will just switch you to presenter. And as Jack said, all of these questions will be posted to the forum, so we can carry on talking about Evan's work there. And Ivan is here, so are you ready to talk?
You are now unmuted.
Sorry, my English is not enough to debate in depth, but Alex going to share a video. I prepare a video, and after that we can discuss about the content of the video. No,
cool. Shall I do that now, Ivan?
Yeah.
Okay.
Okay.
You are now muted.
Oh, change the screen.
You are now unmuted.
Yeah.
También una trans que se llevaba para Michoacán y la encontraron muerta, también tenía ella. Estos niveles de calor se esperan para la región de la costa y el centro. Protección civil emite la siguiente recomendación. Marca por esa atención de costa y la calientes por tratarse con precipitaciones de fuertes a muy fuertes. La línea de
Okay. Well, this is an experimentation with a radio station recording. And can you listen? Yes? Hear me? Yeah. And I create the possibility to the proximity to the angle, select the sample and striate the sample and sorry about my difficulty to explain, no? But I don't know, but if you have some question, it's possible to explain more in more detail, no? The machine and the connection with tidal cycles.
Yeah, you have 1 minute left if you want to talk some more, or we can just go to questions. It's up to you.
What?
You can talk for another minute, or we can just go to questions.
No,
Anybody have questions?
If somebody have some question, it's perfect for me.
Yeah, thanks for that video. It's like a really beautiful installation. We really appreciated the object itself was really beautiful. I wondered if you could say something about the sort of the way that the sound is produced, and the idea of coding tidal cycles to interact with a physical object to then produce sound, and sort of like mediating the sound production via this physical object.
Please, can you repeat slow? please.
Can you talk about coding the physical object in order to produce
Okay.
sound?
Well, the object send two types of data: the tilt and the pan, and sends the lens with obstacles inside the space. No, this is my studio, no? and this and the difference with the previous version of the object is I can with tidal moving the rotation with more complex dynamic, no? Because I involve pattern, no? to move the object, and for this reason the aesthetic is more similar to plunderphonic aesthetic. It's more nervous or more chaotic, no? Because the ramp is not a continuous ramp, no? In the previous version of the object, the oscillation of the sound is more common. In this version, involve this data, no? In this case is in meter the length and the inclination, the angle of the tilt and pan, no? Is the geometry of the object produce the spiral geometry, and it's a metaphor, like the space is similar to vinyl record, no? Mm-hmm. but read the space like a vinyl record, no? The pointer is in the opposite direction, no? To the space, no, not to the. And the disc have only one line, different to the vinyl record, no? And this configuration produce the explicit movement, no? Okay. And I present this project in more big spaces like museum and space, because this object can sense, ¿cómo se dice? 80 to a really big space, no? And it is the object. Sometimes I use the mechanical sound, acoustic sound, and sometimes not. Depends, no? In this case, all the sound is electronic, no? It's only an interface, no?
Mm-hmm. Thank you. That's very clear. There's two questions there. We probably have time for you to answer one of them if you want to. There's one in Spanish in the public chat here, also one from Manu in English. So take your pick. I won't read the one in Spanish.
Yeah. I go to share all the code in my GitHub, no? The original code and the simple version, no? For it's possible to apply to other projects, no? But both versions, no? For some artists or coder is interested in get, no? This engine, no?
Super. Then I think we can, as with the other presentations, then carry on this discussion via the forum. So thank you so much for your beautiful video talk. And I think we will move.
Thank you for the invitation. And sorry.
No, it's fine. Okay. It was great. So then we move on to the last talk, which is Rafaela, who I hope is here. And thank you, Ivan.
Thank you.
So I'll make Rafaela the presenter, and hopefully she can turn her audio and video on. There you are. Great. So this is Rafaela Andrade. I don't know how to pronounce your name. Sorry.
Oh, it's fine. Or Rafa, it's also okay.
You are now unmuted.
Don't care.
You are now muted. You are now unmuted.
You're very quiet.
You are now muted.
Oh. Now. See. Better?
It's the same.
The same.
Yeah.
Okay. Here. Super nice presentations that we just watched. Super nice projects. Love it.
Yeah.
I'm using a different computer, so to discover how to make that. It's very quiet that you cannot listen me at all.
For me, it's okay. I don't know how it is for the live stream.
Okay.
Alex, do you have an idea if it's loud in the live stream?
You are now unmuted. You are now muted.
Yeah, you see, like I go here and then be here, but solving troubles online on live. No, if it's not such a big deal, I'll just start it and then what do you think?
You are now unmuted.
The people on the live stream are saying it is quite quiet.
Yeah.
You are now muted.
Okay, super.
Right. Yeah, that's better, I guess. Right. I was thinking to share my screen like this because let me see. Whiteboard, is it possible to import PDF?
Yeah, so there should be like a plus button at the bottom, and there's an option there to upload a PDF.
That's better. Okay. So maybe I'll just start to introduce myself. I am Rafaela, as you know. You probably listen. And I am from Brazil, but I'm currently living in the Netherlands. And I am presenting today a short presentation about reprogrammability. Loading. Yes, and I created an instrument that hosts this practice, and I'll be doing a master now for the coming 2 years about that. And I'll be glad to share with you what is gonna be this master. I mean, this study about this project about. And it's still uploading. Yes, here we are. Sorry for the delay. Yeah, so here we are. So before I go into all the details of this project, I want to say something about me and my project. As I said, my name is Rafaela, and I study composition conducting in Brazil as a part of one bachelor degree, and I just finished another bachelor degree in sonology and I'm going for the Audiences in Innovative Practice Master Program, also in the Netherlands. My background is completely about contemporary music and producing scores with different typography, symbols, as you see in these pictures, like some kind of symbols of foods and some symbols of intensity in the bow. And I have a big, not as a super experience, but I had a big experience in time producing my own compositions and producing concerts about diversity, music with gender and culture in Brazil. And this is, this was an amazing time looking after almost 5 years now. But as we saw as well in the Magno presentation, you start to realize when you start to do pieces, artistic artworks, that the interface that you always use, it's your biggest limitation. And that becomes also part of your frustration as an artist. I just loved all the presentations because I'm just gonna talk about all these comments. I'm just gonna answer these comments about those presentations. This is one of them. So my first insight about all these things, all this experience before, was about my instrument. So I play cello and I'm a cellist. And I used to carry this instrument for my whole life. It's fucking oh my god, sorry, I cannot say these things. It's very heavy. It's very difficult to carry it, to transport. Sometimes you have to pay for a seat to transport from Brazil. And if you add all your electronic devices that you might have if you are doing electroacoustic compositions, it's very stressful, and it's very limited again. And the instrument itself, it's an instrument that reflects discussions that was developed in the latest 16th century. And the part of the One Healthy that I wrote here in this paper, in this doc, it's proved by some doctors that this is cello. It's actually one of the most unhealthy instruments because you always have to sit like this, very curved, and this is very, very unhealthy for your back pain, or for your back. It can bring back pain. So this was one thing that I realized, and then I started to think, okay, let's just find out and build an instrument that can improve all these things and can discuss recent reflections about performance, composition, the design of performance, the design of a system for composition, for music performance. So this is Kinrow. This is the instrument that I built. It's a cello with 16 strings, and there is some capacitive buttons around the neck. There is 4 speakers connected in Siri. But the 3 most important things of these instruments is that it's a hybrid instrument. So it's an instrument that it's electronic and acoustic. And it's a self-contained circuit. I mean, it contains self-contained circuits. So speakers, microphones, and microcontrollers are all attached to the instrument. And it's a mobile instrument. So, and I also bring some discussions about sustainability as well in the design. So it's made with a recycled PETG, and so it's powered by solar panels. So this is just one more picture to give a more detailed picture from what is this instrument. So you can see the solar panels. And the speakers, I have my controller inside, the Bella, and it's in this box here. You can see as well one of the capacitive buttons here. I have also a LED screen. I have a lot of different types of feedback. I have a live coding interface, but I also have a LED screen in my bow. Yeah, and another thing that I was asking myself about these hybrid proposals is the type or the kind of performance that was bringing. So usually when you're doing classic or contemporary modern concerts, you can see, I bring all the examples about Yo-Yo Ma, but it's just so funny. Anyway, you can see that there is a lot of things that it doesn't match so well with the way that you are, lack of engagement that you usually have. So in a concert, you can really realize that the public can really not interrupt, or they are really not welcome to participate actively from the performance. That virtuosism, it's something that it's really fundamental for performance itself. In virtuosism, it is a romantic idea, so those two items are also correlated. But also that a concert, a classic music concert, has and contains a lot of lack of culture and gender diversity. And all these items that are actually the issues of this kind of classic performance type. They are part of the whole thing about performance itself. I mean, they are really like they are kind of like the cause and effect of each other. So I'm creating and designing and practicing myself a performance where I can bring in one instrument, different types of aesthetics, and also a way to make the audiences and performances part of the interactivity, part of the performance itself. So they are allowed to change things in the performance. So they are basically not passive listeners, but they are active. But yeah, and the third thing that now it kind of symbolizes or kind of filter these things that we just talked, that are actually objects, performance in the instrument. This is more about the concept, the format, which is reprogrammability. It's basically reprogrammability is basically a variation, I would say, from live coding. That it's really about the practice itself, bringing this concept for different parts of a performance. So the system design, the production, and the concert. But my time is off. I'm sorry. So these are the things that I am exploring in my master. And of course, I'll be happy to hear from you, and you're more than welcome to check and to keep following these future developments. There will be some workshops in October in the Gaudiamus, some simulation labs in the instrument inventors. It's not really something not how can I say? It's just some actually live coding sessions, so you can just check my Instagram and they will be there. And of course, now it's time for questions, and of course you can always check these links as well if you want to hear more or listen to some music And for the presenters, if you want to show your screens here and we can talk, it's also fine for me.
I hear I may be very loud now, so please someone post if I'm deafening you with my microphone. Yeah, thank you for that beautiful presentation on your instrument, which I've seen you perform with like quite a few times now, and it's always super interesting. There's been quite a lot of comment in the chats while that was ongoing, so I'm hoping that people have some questions, and we probably have time for one or two. Maybe while we wait for questions to come in, could you talk a bit more about the reprogrammability, which is really hard to say, of the instrument?
Yeah, that's such a difficult word. Yeah, so the fact about the reprogrammability, I made even a paper for myself because sometimes you can really lost your mind with so many concepts and things related to the project. But basically the idea of reprogrammability involves changing what, so changing variables, conditions, and functions, or changing who, the audience, the performers, or the collaborator. Collaborator, I would say the other performers, like coders, or multimedia artists. And but also involved changing how, and yeah, that's also. So how could you change your performance by reprogrammability? So I would say by different methods of tracking, the counting, generation, filtering, processing, and triggering, because trigger is something that in circuits you can realize how many approaches you can add and you can apply in your design. That's maybe a good summarize of.
Yeah. We have a few questions from YouTube. Maybe we'll go to Jonathan Royce, who asked about the transportability of the instrument and also the future goals for the form and design. And maybe there's also a question about if it works acoustically too. So that's sort of, I guess, in the same question band.
Yeah. Okay. Yeah, so the acoustic part, yeah, it works also without power. It's not loud as a cello, but it works as an instrument, acoustic. So for example, I can play, like if I play loud at my apartment here, the neighbors can be annoyed by the sound. So it's kind of loud already. And it's funny because when you think in plastic, you think like, okay, this is not color that you would think that an instrument, we could think in an instrument, you know, plastic is a bit like you already have this idea of, oh, okay, it's a toys material. But actually has a very nice, what is it? It's a very nice acoustic impedance. But about Jonathan's question, so the transport, it's really nice that I have different components in the instrument's body. So I have a bar inside, and this bar is actually supporting the whole structure. And if I want to bring to the airport, I kind of hack this mode of airport cellist in the airport. So I just unpack everything, and then I put everything like in this size, because all these parts they go inside of each other, and then I can just bring it in my suitcase. So it's pretty easy. But of course, it's not something that I would do every day because it takes time. So it's easy to transport for long trips. For normal trips, like going to your work, it's kind of the same. So, but the only thing is that it's smaller than a cello and also lighter, way lighter.
I think we're out of time now, so maybe we will push the other questions that came into the forum, and we can carry on discussing that there. And actually that concludes, and thanks Rafaela for your talk, that's great. And that concludes the session. And I think we're going to take a short break before we carry on a whole new YouTube link for heritage algorithms.
You are now unmuted.
Yeah, that's right. I'll stop this stream for YouTube watchers and be sure to follow the link to the new stream. Let's have like a 5-minute break and reconvene after a good, don't forget to stretch, have a glass of water, and see you in 5 minutes with the next session.